In example number 6, we want to write the equation in vertex form, and then we want to sketch the graph of the function. So the first task we want to do is we want to write this in vertex form. So I want to rewrite this just to give me a little operating room here. X squared plus 6x minus 7. The first thing I want to do when I think about putting it in vertex form is grouping the x's. So once we group the x's, we can see if we need to factor anything out. I need to factor out that -1. If this is not a positive 1, this number here, then I need to factor it out. And since it's a -1, we must factor out a -1. That'll change it to a positive x squared, and that'll change it to a -6x. I'm going to leave a spot here to complete the square, minus 7. I'm going to leave a spot here to balance it. So now I'm going to go ahead and go through the process of completing the square. We're going to take half of 6. Half of 6 is 3. And then we square the 3, which is a 9. So I want to add a 9 in here. So it looks like we've added 9, but if we really consider our negative out front, we really didn't add 9, we really subtracted 9. So to balance, we have to add 9 out here. So that's just a matter of keeping it balanced. So now we're going to go ahead and factor our trinomial square. So it's negative x minus 3 squared plus 2. Now this gives me the directions to get to the vertex. So to get to the vertex, what we want to do is we want to go 3 units to the right. So we go 1, 2, 3. Then we go 2 units up. So up 1. Oh, there's good thing I noticed that is a unit of 2. So each tick mark is a unit of 2. So I only have to go 1 tick mark up, which represents 2 units. So the vertex is right in here. It is the order pair 3, 2. Right. Then what we want to do is we want to pay attention to our reflections, and in this case we have this negative sitting out front, or we have a negative there that was telling us it was frowning, so our graph has to open downward, and since it's a 1, our normal changes on these is when we go to the right one. I'm going to go a different color, but if we go right 1, we'd only go down 1, but because we have a negative there, let me back one more time. I'll try it one last time. Typically when we do this, we go right 1, up 1, but because it's negative, we go right 1, down 1. That 1 doesn't stretch at all, but we go right and then down 1 unit. So here's a point. Then we go left and only down 1 unit. There's a point. I'm also going to use this order pair to help me out. It has to cross the y-axis at -7, so I'm predicting that's somewhere in there. And it's got to be symmetrical to the vertex, and the vertex is here, so I got to go over 3 units to the left and 3 units to the right. So there's 2. Make sure I got this right. That's 3 units. 1, 2, 3. So right in here, it's got to come out again. So I have a parabola that's coming downward like this and like this. So I use the y-intercept to help me graph another point on there. If you really wanted another point, rather than going right 1, down 1, you could go right 2, and then we normally go down 4, so go down 2, 4, we're back on the graph. You go left 2, we normally go down 4, 2, 4, we're back on the graph. But there's our graph and our vertex form of this quadratic function.